Welcome in, Psych students. This is Professor Zeeb, and welcome to our lecture on the limitations of attention. The basic points we're going to make here is that as humans, unfortunately, our attentional skills can be limited at times, and especially when we are having to pay attention to multiple things at once. So we're going to look at some classic examples of this as we go through. So the very first thing we're going to do is a little experiment. So I'm going to recommend that you take a moment to get a timer and possibly someone to help you and observe you during this experiment. So go ahead and get your timer and partner at this time and pause the video. Okay, so hopefully you've gotten your timer and your person ready. What we're going to do is I'm going to show you the next screen here. And as quickly as you can, I want you to say out loud the color that the words show up on the screen. So for example, if we're looking at this screen and we see the words limitations of attention, that's obviously in black, you would say black, black, black. So there's going to be several words. Read the words as if you're reading a book, starting at the top left and going left to right. Do it as quickly as you can without making any mistakes. I want you to time yourself and have your partner just basically watch you and record if you make any errors. So for example, if you say the wrong color or you say red, no blue kind of thing, that would also be an error. All right, so get your timer and your person ready, and we'll start on the count of 3. 3, 2, 1. All right, so hopefully you finished that. Usually for this one, people don't have any problems. They're very easily able to say the color that it shows up on. So we're going to try it one more time. So if you'd reset your timer, get your partner ready to go. And once again, the exact same thing, as quick as you can, read the words out loud in the color that they show up in, and do it as quickly as you can without making mistakes. All right, so we will start 3, 2, 1. Okay, so hopefully you finished that. The point is pretty obvious here that the second task often takes people longer. So I want you to compare your two times and compare the amount of errors you made between the two tasks. What we're saying here is that in most cases, in the second one, it usually takes people a little bit longer and they often make more mistakes. You can see obviously why that is because when we look at this particular screen, these words are actually showing up in a different color. So for example, right here we see the word yellow. You just want to, it's blue, but you just want to say yellow. I mean, I just demonstrated that. So the point is that you're having to pay attention basically to two things at once, and it sort of slows you down a little bit. So this particular experiment is very classic. We call it the Stroop Effect. So let's take a look at that. And thank you for your timer and your partner for helping you. So the Stroop Effect, this famous experiment where it's the tendency to read the words instead of saying the color of the ink they show up on. So in other words, we find that it's very distracting for people because they want to read the actual word, being colored words, obviously, and it sort of drains your attentional resources. So it just basically shows that sometimes when you're doing a similar task, depending on the requirements and the circumstances, it may actually drain your attention more and people find it difficult. So just to kind of summarize that one, people typically take longer the second time and make more mistakes because it is draining your attention more. Here's another example. Let's say that you're an engineer and you're building this machine for some type of plant or something, and we have two rows of dials. We have the top row and the bottom row, and we want to construct this machine in such a way that the person can quickly see if that red needle is in the green region. So if you look at up here in the top, we find that this one is pretty draining for the person because they have to find the green region and then find where the red needle is. But see in the bottom row here, notice that the green region is always in the same area. So thus, half the work is done for the person. We find that the second row is much more efficient and easier on the person because the green region is in the same location in each dial. So the point is that if we were constructing a machine, we would take this into account, especially if time mattered in terms of the reaction time. We'd want to construct the device, those dials in this sort of manner. Once again, because our attention can be limited at times, we can take certain measures to make tasks more user-friendly in that sense. All right, so further continuing with the lecture here, we're going to look at shifting attention. In other words, this is a case where someone is paying attention to multiple things at once and going back and forth. What we've discovered in the studies is that attending to one thing detracts from attending to something else, which would make sense. If you have to pay attention to 3 different things at the same time and you're shifting back and forth, obviously that would be much more draining than focusing on one thing at a time. And yet people do this all the time. I mean, I see it on a daily basis on the road. I see it in the classroom. I see it at work. People really think that they can do this without any consequences, and what we're finding is that's not the case. We're finding that it actually does take a little bit away to the point where it may affect your performance. The textbook gives this great example of how some students bring their laptops to class to take notes, right? And as a professor in the classroom, I welcome that. I think it's great that students can use technology to help them take notes. Okay, but what this study, which was done by Fried 2008, they compared the grades of students who bring their laptops to class to those who don't. So theoretically what we're saying is that, well, if they're bringing their laptops to class, they're taking notes in an efficient manner, the grades basically should be better, right? They have found that's quite not the case. In fact, their grades are lower. So students who bring their laptops to class, their grades are lower than students who do not. Why is that? Well, I think it's pretty obvious. The point is that laptops may be distracting you from the actual lecture. In other words, obviously laptops do many things other than take notes. They could be surfing the net. They could be playing games. They could be shopping. Who knows what they're doing on their laptop? But the point is that that attentional drain may take their attention off the lecture where they may be missing points that are sort of mentioned in class. So as students, guys, you have to think about this when you're taking your face-to-face classes, is that sometimes technology definitely can help you, but you have to realize, is it worth the potential effect of distracting you to the point where you're missing points in the lecture? So I thought that was interesting. Something that's designed to help you in the classroom may actually be hurting you. I thought that was kind of funny. All right, so the classic example of this one, guys, and this is something I see every day on the road. Well, not this particularly, but you understand what I'm saying. People are using those phones when they're behind the wheel, and obviously it is illegal to do so in terms of holding your phone or having it distract you. The reason, obviously, that it's illegal is because we've tied this to many different problems, including accidents. Research has shown that using your cell phone while driving decreases your visual attention and increases the risk of accidents. So we have directly tied this to accidents. In fact, I know several people who have had this problem. What we're thinking is that your attention on your phone may be enough to delay your reaction to such an extent that you cannot react quick enough. As drivers, we all know that you cannot predict things. You never know when someone's going to suddenly slow down or something's going to cross the street and you have to swerve. In other words, your reaction time may be dampened to such an extent that it could actually make the difference where it's a fender bender a serious accident, or worse, someone is really hurt. In fact, we've had people, unfortunately, killed while using their cell phones and driving. So obviously that's why we don't want people doing it, because it does distract you. In my personal experiences, I've just basically noticed that people drive slower than normal when they're using their phone. They're swerving in their lanes, or let's see if this has happened to you. You're sitting at a red light, they're on their phone, the light turns green and you're behind them. They don't go and they realize it at the last second. Oh, I got to go. And then you end up missing the light because of this. This actually happened to me the other day. It's not the end of the world, but once again, it kind of sucks because now I have to wait through another cycle of lights because you weren't paying attention. So we're finding that people are just not following the rules at times and are being distracted by their devices. So guys, please think about this. Is your life worth the risk of checking a message or doing whatever you're doing on your phone? So you have to think about that, guys. That's why we have these laws, is to protect people. And the way I think of it is, if I'm on the road with my kids, I want people paying attention to what they're doing. I don't want them on their devices. Okay, so we will move on, guys. We're going to go to a related concept, and this is called half-a-log. So I thought this was interesting in the book there. Let's say you're driving your car and your passenger is on their cell phone and they're talking with someone through their cell phone. Do you ever find yourself listening in to their conversation? So you're driving, you're paying attention to the road, but you might also be following the conversation. Remember, in most cases, you can't hear the person on the other end. So that's why we call it half-a-log, is because basically you're only hearing half of the conversation. This can be a problem because we've found that people are mentally trying to fill in the gaps of the conversation. In other words, as they're listening along, they might find themselves imagining what the other person has just said or their reaction to the comment. So in other words, it may be distracting enough where it's taking your attention off the road. It may be creating problems paying attention to your driving. So ironically, you may not even be on your phone, and yet it may be as distracting as if you were. So I thought that was really interesting, that people are mentally filling in those gaps, which takes mental effort and may be enough to distract the person. Okay, so we're going to look at another example of how our attention is limited. We go to this research and concept known as the attentional blink. Basically what this means is during a brief time after perceiving one stimulus, it is difficult to attend to something else. What we mean by this is that if you're paying attention to one thing, you may miss something that immediately follows it. So in other words, two things are happening in time, one after the other. Your focus is so much on the first one, and you're still processing it, that you may actually miss the second one, especially if it occurs close in time. So thus, you have blinked in your attention, so to speak. So we're going to look at a study that basically showed this. In the study, subjects were seated in front of a computer screen. We're going to go to this white screen here. And they would string up these letters one at a time. Each letter was shown for 0.09 seconds each in a string. And the person would be asked to identify the blue letter. So as you can see, the blue letter here is B. They found that subjects had no problem doing that. The blue number was very easily noticed. Most people could get that right, even if there was like 50 letters in that string. In the second task, what they did this time is they showed the string of letters once again. The person had to identify the blue letter, but they were also instructed to say yes or no, was there a T present as well? So in other words, they're looking for two things. You have to identify the blue letter and then say yes or no, was there a T? Here's what they found. If the T occurred very close in the string, they found that people would often miss it. In other words, they're so paying attention to this blue letter, and they're still processing it, that they may miss the T and they would say no. However, if the T occurred way down the string, they found that they more than likely could get it correct. So thus, what we're saying is that if that T is really close to the blue letter in the string in terms of how it plays out, you may actually miss perceiving that, and thus you've blinked in your attention. So they discovered the attentional blink range is about 100 to 700 milliseconds. In other words, if the T occurs within this range after the blue letter, most people would miss the T. They would report that they did not see it. However, if it was before it, or even after 700 milliseconds, they've now processed the blue letter. Now they're looking for the T. They would be able to capture it. So we think our attentional blink range is about 100 to 700 milliseconds, which shows within a second or so that T has occurred and the person may possibly miss it. What that basically means is that sometimes we miss things that are back to back. You may be so focused on one thing that you're actually missing the second event, and thus you have blinked in your attention. Okay, so once again, we're just sort of showing that unfortunately our attention is not limitless. It has some problems that obviously as humans we need to be aware. So please take these into consideration. That will do it for our short lecture here, and so please progress to the next step.